All right, so here is 2 examples from practice 7. This is going to be numbers 3 and 4, okay? All right, so number 3, how many kilojoules of energy would you expect to be transferred? Whoa, what happened there? Oh, brother. Okay, here we go. How many kilojoules of energy would you expect to be transferred when 6.44 grams of sulfur react with excess oxygen gas to produce sulfur trioxide? Is this endo or exothermic? Okay, so here goes the equation that was given. 2 sulfur plus 3 oxygen make 2 sulfur trioxide. Okay, and it says delta H is negative 791.4 kilojoules. Okay, and I don't know what that little circle is. I don't know what happened there, but okay, all right. So just like a regular stoichiometry problem, you're going to start with what's given. Okay, and in this case, it says 6.44 grams of sulfur. Okay, so you're going to have to start with 6.44 grams of sulfur. All right, and it says with excess oxygen gas, that just means there's enough for the reaction to take place, that sulfur is the limiting reactant. Okay, so you're always going to do the same thing. You're trying to just start with something and get to what you want. Okay, in this case, I want energy. All right, so the first thing I have to do is I always have to get to moles, right? Because this means 2 moles of sulfur and 3 moles of oxygen and 2 moles of sulfur trioxide, okay, go with negative 791.4 kilojoules. All right, so in the reaction, if I use up 2 moles of sulfur, that's going to correspond to an energy of 791.4. All right, so then 1 mole of it would be half of that, which would be just under 400. Okay, so this is the coefficient, the coefficient, the coefficient. This is sort of like a new coefficient. All right, it works just the same way like in the stoichiometry problems. All right, so the first thing, anytime you have grams, you're going to have to go to moles first. Okay, so I'm going to say 1 mole of sulfur goes with 32.07 grams of sulfur. That's the molar mass. Okay, so you're always going to have to use the molar mass to go grams to moles, or moles to grams, whatever you need. Okay, all right, and now I can do ratio, right? So this used to be the ratio step, so grams of sulfur have canceled. So now I know that I have moles of sulfur. All right, I'm going to now use the ratios, and I know 2 moles of sulfur here, okay, are going to correspond with 791.4 kilojoules of energy. All right, because that's kind of like a new coefficient. All right, so when I multiply 6.44 times 791.4 divided by 32.07 divided by 2, okay, I get a net of 79.5 kilojoules of energy. Okay, and since this is a negative delta H, that makes it exothermic. Okay, and the graph would sort of be reactants, okay, split apart, and then it's going to be exo, so it's going to actually have a lower energy in the products, all right, because my delta H is going to be negative. Okay, they're all just the same way. Whatever you start with, if it's grams, you have to use the molar mass, then you have to use the ratios from the coefficients, okay, and the energy is kind of like a new coefficient, and then you get the answer. Okay, all right, so that was number 3. Let's try number 4. Let's see, new, don't save. Okay, all right, so number 4 says nitrogen gas and oxygen gas can combine to make nitric oxide, NO. Okay, if such a reaction absorbs 88 kilojoules of energy from the surroundings, how many grams of nitrogen gas do you predict were consumed? Okay, so here goes my reaction. N2 plus O2 makes 2NO. All right, and the delta H is telling me is 180 kilojoules. Okay, and since that's positive, I know it's endothermic. And it's also asking me how much energy was absorbed from the surroundings, right? That means energy is going into the system, which makes it endothermic. Okay, all right, so energy I'm going to put on this side of the equation. I think I forgot to do that on the last one. All right, and now I'm going to look at my ratios. I have 1 here, 2 here, and that corresponds to this amount of energy. Okay, so if 1 mole of nitrogen gas is used, that's going to correspond to 180 kilojoules of energy. Okay, so the given thing in the problem this time is the kilojoules. It says it's going to absorb 88 kilojoules. Okay, so look, it's not quite as much. It's about half of that. All right, so it's about half of that. All right, Now I'm going to use the ratios, okay, because I have kilojoules. This is the only other place I have kilojoules is here. And I want to correspond that to what I want, which was the nitrogen gas. So that's 1 mole of N2 because this is a 1, okay? All right, now it's asking me for how many grams of nitrogen gas. So I have moles, so now I have to use the molar mass. Okay, so 1 mole of N2 corresponds to 28 grams of N2. Cancel, 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 cancel. All right, and then I'm going to multiply all of this out, and then I'm going to get 13.7 grams of N2. Okay, so this one was a little bit backwards. I started with energy, so I'm going to do the ratio first, then I'm going to do the molar mass. Okay, and this is endothermic, so that means if I start with my reactants here, energy in is going to split them apart. Okay, and less energy comes out because it's a net endo, net positive. So then my delta H here is going to be positive. Okay, all right, hopefully that helps, and I'll post the answer key, and the answers are also on the sheet.